As part of the AMS 2750 CQI9 temperature uniformity survey, a critical requirement of the work is to ensure that the sensors being used with the field test instrument or the data logger are within specification, are accurate enough to give you the confidence in the data that you're providing. Within the standards themselves, there's a clear documentary requirements as to the type of sensors that can be used and the specific accuracy that needs to be achieved for the use of those sensors. The type of thermocouple, for instance, whether it's a base metal or maybe even an RNS thermocouple. One important thing to take into account is that when doing a temperature uniformity survey, there is a choice of two types of sensor. One is referred to as an expendable sensor, where you've got an exposed junction where the measurement is being taken, as you can see in the top image of the glass fiber cable, or a non-expendable sensor where the hot junction or the measurement point of the sensor is actually encased with a material that will provide protection against damage within the process. This is generally covered by the mineral insulated thermocouples that Phoenix Temperature Measurements supply. Phoenix offer a range of different thermocouples for use of standard temperature uniformity survey work, but it's important that, to note that all of the thermocouples are rated to either ANSI MC 96.1 with special limits of error, or the IEC 605-84 Class 1 specification. For the ANSI spec, all of the thermocouples are rated to plus or minus 1.1 degrees Celsius, or plus or minus 0.4% of the reading being taken, which satisfies the standard that we're working to. Ensuring that the thermocouples are accurate is important, and having the necessary documentation and certification to back that up is essential. But an important part of the temperature uniformity survey is actually applying the information from the calibration for the thermocouple to allow you to perform what we call thermocouple correction for the test data itself. As we saw in a previous video, it's possible to create, like for the data logger, a correction factor file. We can do the same thing for our thermocouples. Within the software, you can create a correction factor file for the thermocouples that are used for the survey. In the top right hand corner here, you can see the layout of the table, which looks very similar to the data logger correction factor file. But all we do is manually build up a table for, as you can see here, up to 20 thermocouples. The thermocouples are actually manufactured from 2 batches of thermocouple wire with different possible calibration certificates. And what we're doing is we're incorporating into that table for each temperature reference the roll start temperature, actual achieved temperature, and the roll end actual, taking data directly from the calibration certificate that we have for the batch of thermocouples that we're using. Then the software will automatically calculate from that information the roll start information, the roll end information, an average calculated correction factor which needs to be applied at the relevant calibration temperature, which is then applied to the actual TUS data itself. It's important to note that the correction factors are accurately input over the entire temperature range of the TUS to match the calibration certificate, and they're calculated from the use of start and end roll calibration data itself. One important aspect of the thermocouple correction factor principle that Phoenix Temperature Measurement uses is that although we are putting in defined correction factors at nominal temperatures, so in this case 0, 500 and 1000, As for the data logger correction factor analysis, we use a technique called linear interpolation to allow values within those calibration points to be calculated accurately from the linear least squares algorithm. This means that all of the data across the whole TUS is calculated and corrected for accurately from this data. The correction factors for the temperature between calibration points is also included in the analysis, and therefore if the TUS temperatures don't match the calibration information, we are able to then give a defined correction factor that was applied at each respective TUS level. To give full certification to the thermocouple correction factors in the TUS report that the Thermal View survey generates, we give all of the information created within the correction factor file. And as you can see here, as I've said before, the calibration for this particular thermocouple was done at 0, 500 and 1000. The TUS temperature was actually though at 800 degrees, but using the linear interpolation method, we were able to calculate the corresponding correction factor at 800 from the calibration data itself. So we satisfy everything we need within the AMS 2750 specification and also CQI 9. So let us now investigate how we can apply a thermocouple correction factor file to a TUS run and also create a new file, a new thermocouple correction file from scratch. For the TUS run that we have visible on the software screen at the moment, you can see from the database that we have a logger correction factor file applied to the data, but no thermocouple correction file linked automatically. That's confirmed in the top left-hand corner here, where you've got a red cross against the thermocouple corrections applied. So this is a non-corrected TUS run in terms of thermocouple corrections. To apply a correction factor file, I simply go to the TC connection correction button, and I'm going to call up from the list the appropriate thermocouple calibration correction factor file for the run I've just performed, and it's in fact this case here with file 1004. So if I click on that, I can see now the data that has historically been put in for the correction factor file. So for the run, which is a 9-point TUS, thermocouples 1, 2, 3, 4 through to 9 are all from one batch of cable, calibration certificate 1, 2, 3, 4, and one thermocouple number 4, was from a second batch of cable, which was calibration certificate 4, 5, 6, 7. So for the two batches, I have two separate calibration tables set up. For 1, 2, 3, 4, I've got a calibration table ranging from 700 to 1300 degrees with the roll start end values and the corrected correction factors. And for the single thermocouple on its own, thermocouple number 4, a different calibration, but again over a similar temperature range that covers the TUS that we're actually performing. To apply this, as is convention, I simply attach the apply to current survey, and you'll notice now that the survey file, the correction factor file, is now live on the database, and the status is updated in the top left-hand corner of the software screen to indicate that both data logger and thermocouple correction factor files are applied to the TUS data that we're now looking at. So how do we create a thermocouple file from scratch? What I'm going to do first of all is go to the file library header and go to, as convention has it, add new. I'm now going to choose my file name, so I'm just going to call it Offley TUS. I've got a type K thermocouple, and I'm going to use a 10-channel data logger, so I'm going to apply 10 channels here. I could pull back a historic calibration file and edit that, but I'm not going to, so I'm going to click on OK to create a new file altogether. So you see the table is empty. So what I need to do first of all is add the batch of cable that I want to add my calibration data for. The calibration date 16th of the 4th, 2025. I'm going to call it 1234, calibrated by myself, and the calibration certificate is 1234. Okay. Now for this batch, I know that the first 4 thermocouples I'm going to use, channels 1 to 4, are from that batch. So I'm going to add a generic 3-point calibration. So I've got 0, add value, 200, add value, 400. Obviously these temperatures would be matching what's on the calibration certificate. I would then put in the actual roll start values and the roll end, and it would then automatically calculate it. So for instance, just to show you how that would work, I'm going to say that the actual temperature at 200 is 200.1. Both start and stop, and you can see here that that would then generate a calculated correction factor applied to the TUS data at 200 of minus 0.10 degrees Celsius. Okay, I'm going to add another batch. So in this case, it's going to be 5, 6, 7, 8. Again, calibrated by myself. 5, 6, 7, 8. Okay, and in this case, I'm going to have thermocouples 5, 6, 7, 8, and 9. And in this case, I'm going to again add 0. Second calibration point is 200. 400. Okay, so I would again put in the actual roll start and the roll end actual values from the calibration certificate, basically transposing the data from the certificate itself to the software, and then it would automatically do the calculation. Once I've finished, I simply press finish, and that will now save that correction factor file in the software. To apply the newly created calibration or thermocouple correction factor file, I simply have to go to the TC correction button in the settings library, and I would then find the file. Luckily enough, from the list it's come up automatically, and I would then apply that to the current survey. And you can see from the database table now that the new file, the newly created file, is updated on there, and the status in the top left hand corner of the software implies that that file has been applied to the TUS data itself.